Hello everyone, I'm Ling Chen. Here is our group members Ran Heng, Wu Shaoyu, and Su Ruixiang. And this is our final project. Our topic is sleep and take your time. How we come to this topic is because our topic have to relate it to time measurement, but we cannot think of any clock to measure the second. So then we choose to measure a day by sleep. That almost everyone will do once per day. But this project had to stop because our wrong unit. I will explain then. And then we come to the measure the day sleep time. Still related to the sleep. And how to measure the deep sleep time is by the rollover times between two rollover, the time between two rollover. And we can use this. If it is long enough, it will think it is deep sleep. To do that, we will buy a sensor and Arduino. Sensor is to change our move to the signal, and the Arduino is to read the signal and change to the digital output. Here is our sleep period. I will start at least some times, and you can see that and we want to do that by Arduino and sensor and display unit. Our display unit use the 7-segment display because we only want to show the time by minute, so it is enough. And the 4 numbers is enough because we won't sleep more than 9,999 seconds, so minutes, so it is enough. And then our sensor will put here, and Arduino here will have some program we will outload then. And we use this simple picture here, but our real sensor is here. It will use the vibrate. It will detect the vibration. If the upward of this vibrate, it will have voltage output, and when it is vibrate more significantly, it will have the higher voltage output. So we can use this to design the length of our program.
When we get a signal from the sensor, we first determine whether the signal comes from rollovers or other vibration or noises. To do that, we set a threshold value. According to our experiment, we define the threshold number 1.7 volts. When the signal is greater than 1.7 volts, we can say that the signal is caused from the rollovers rather than noises. Now we can detect the rollovers easily. The signal caused by rollovers passed into Arduino. The signal then from analog turned into digital. The Arduino microcontroller keep timing from the beginning. Once we get the rollovers signal, Arduino will record the time interval between two rollovers. Our main goal is to record a person's deep sleep time. People roll over fewer in deep sleep than they are in light sleep. We use this property to determine whether the time interval we recorded is during deep sleep. Some research show that humans roll over about 20 times a night. Therefore, for example, if a man sleeps 5 hours each night, since the man often rollovers in light sleep time, but seldom in deep sleep time, we can determine the deep sleep threshold is 5 hours divided by 20 minutes, that is 15 minutes. Then the time interval between two rollovers is greater than threshold number, then we will consider the man is in deep sleep. We can look at this picture. This array records the time intervals. This is the first and the second rollovers interval, and this is the second and the third rollovers time interval, and so forth. This red number is greater than 15 minutes. That means the man is in deep sleep during this time. Plus all this time interval, and we can get the man's deep sleep time. We have a 7-segment display, and it's only display deep sleep time. Once the time interval is in deep sleep, it will display on the 7-segment display, and is cumulative. This is the animation to simulate our project.
This is the C++ code in Arduino to measure deep sleep time. In our implementation, no Python code is used. In the first two lines, we include two libraries, event.h and timer.h. These two libraries contain an object called timer, which will count every second in a time interval. The threshold defined here is the threshold value for a signal to be regarded as a rollover, not a noise. Timer 1 second counts every second. It's an object of the timer.h. The variable time will record the length of each interval between rollovers, and the variable total deep sleep is the accumulation of each qualified time interval. At the setup stage, we set up the baud rate to communicate with the computer. A0 to A2 are set to be sensor inputs, which are analog values. Pin 0 to pin 11 are arranged to output to the 7-segment display in order to display the value of total deep sleep time. And this function at the setup stage actually works as an interrupt. Every 1 second, the function will be triggered, and the time interval is incremented. This is the time interval length, and it will be incremented. We use simple logics to display the 7-segment display, or turn it off, or turn it on. Let's look at this section of codes. It's the loop of the Arduino. As its name suggests, the loop will run over and over again on Arduino. At the beginning of the loop, the timer is updated. This line indicates that whenever Arduino is reset, all variables are also reset to 0. The conditional statement here is the core of our plan. We use logical disjunction to determine whether to process the data from the sensors or not. This condition says that if any of the sensor inputs is greater than the threshold value, the predefined threshold value, then it is seen as a signal of actual rollover, and we will accumulate the total disk sleep with the increment time interval in units of minute. If all sensor inputs are smaller than threshold values, meaning no rollovers occur, then these inputs are ignored. This way, we can block the undesired noises and process the signal of rollovers. Eventually, we display the time of total deep sleep, which is the total time during the deep sleep.
First of all, let me introduce our demo process. That is, put the pillow on the sensor and then lie down and it will stop timing until when you turn over. The 7-segment display will show the time without turning over, like this. This demo process is slightly different from what we actually want to achieve. We hope our deep sleep time will be calculated and displayed on a 7-segment display when we do not turn over for more than a period of time. However, due to the excessive length of the video, is too long and cannot be shown in the demo, so it is only changed to 5 minutes. In addition, we also encountered another problem. Because the sensor did not generate a signal when the pressure doesn't change, but the Arduino is still receiving data. Hence, a lot of noise be received. So as long as the noise exceeds our predetermined threshold voltage, it will also be regarded as turning over. So we can only increase the threshold voltage until it's not affected by the noise. The downside would be that sometimes a slight rollover would not be detected. This is our final project. Thank you for listening.